1983 Atari Star Wars PCB set. This I just put on the bench. I got my harness out and got it hooked up. And I did fire it up once to see what it was doing. And yes, it is as described by the owner. Well, actually, he said it seems to work, but it gives intermittent spot killer on the monitor. And this thing to me seems like it's not working at all. So, and you will see on the monitor the spot killer does flash, but this board is not working whatsoever. So I'll go ahead and switch it on. The LEDs, do they even ever flash? Let's do it again. Because normally these LEDs will be red for a second and then they go out and it starts running. So let's check these things out. What do they do? Yeah, they do. They start up as they should and then it looks like it's running. So this is probably why the owner said it looks like it's running but gives intermittent spot killer issues. And now there's nothing intermittent about that. That's pretty solid. There, flashing there. Let's put this thing into test. Test, and let's restart. See what it does. And still no. It's still doing that. Yeah. Alright, that's enough of that. This thing, I'm going to take it out of test. Okay. So this thing isn't doing diddly squat. First thing I'm going to do is separate all the boards. And this is kind of cool. This is a match set 9192, 9192. And 9192 upside down. So this is an actual match set at the factory, which is cool. So we'll go ahead and lay these out. I'll put the soundboard to the side. I don't even care about that right now. We're just going to get this thing, you know, working, putting a good screen up. And yeah, what I'm doing by laying these out is I'm eliminating this. So let's see what this does without this. And this probably isn't nothing to do with anything, but yeah, let's go ahead and do that. Okay, you got the boards laid out side by side. And we will go ahead and fire it up. Lights are out. It is not running. Same thing. This thing is not running. So let's do that. And I'm going to unplug my monitor. I don't want to keep doing that with that. So we'll hook it up to the little scope, the black scope. And first thing I'm going to do is I am going to go through and do RAM checks on everything. RAM checks, software checks, and socket inspection. So that'll be the first order of business on this set. So let's set up. Alright, now since that thing was acting like it was booting the CPU board, the lights would turn on and then they'd go off. I started with the, because I kind of suspected that board might be fine. So I started with the AVG PCB, and 5 of the 6 RAMs are bad. There's only one that's good. These ones are all bad. So let's put some RAM in the thing and try it out. Okay, so I replaced all 6 of those RAMs because the last one failed as well. So all 6 of those failed. And I've got it on running right now and it's on test mode. But there's no picture. There's no spot killer. But there's no picture. And I know my monitor's fine. So why is there no picture at all? Let's try to adjust some of these things. X center, Y center. Okay. It's nothing to do with size. Pots. Could be blanking. Could it be blanked? I guess we're going to have to get the old scope out and start checking some signals. We'll look for the blanking signal and make sure that the signal that the color signals aren't blanked out or whatever, you know. Something on this board is not right. So it's running though. It is running. Take it out of test. And that's X size. This I believe is Y size. Yeah. I can hear the deflection change as I change that, so that's working. The signal is good. X and Y signals are good, but they may be being blanked out. So we should have a picture. We don't, so. Okay. Now if we take the X signal and make it as big as we can, and the Y, it doesn't even if we do that, it does not fire the spot killer. So yeah, the X and Y is fine. We just have no color. Okay, so let me get the scope out, get the schematic, and look for blanking. Okay, Z intensity and blanking. I can see right now that there is a DAC that is used in the blanking and intensity circuit. So let's just take a DAC and jump over this one and see what happens. See if we have a bad DAC. Okay. Look at that. There it is. Let's change our size on here. The Y size. I want it smaller. About like that. I do not need this very big. Okay. Yeah, so it's got a bad DAC. It looks good. Oh, let's make that X size a little bit bigger than that. And let's go right there. There we go. We have to make sure that the stars are all there and make sure this thing's looking right. We know we have to replace that DAC. Yeah, I think there's supposed to be stars in the background. I'm not seeing any stars. All right, one thing at a time. Well, let's put this thing into test. Let's turn it off. Put it in test and see if it gives us math errors. Okay. Okay. It's telling me that every vector generator RAM is bad. That screams of this chip right here, which is a 245. I've actually seen this before where it said everything was bad and it was this 245. Well, let's do this. Let's grab a 245. Okay. And let's try that. And let's try a restart. See if it gives us the same thing. And it does. Huh, interesting. Okay, so let's try this 245. And restart. Now it says the ROM's not bad. Now the ROM's bad again. So I think this chip's probably bad. And we need to, let's, one thing at a time, let's replace this DAC. Boom, there goes the screen. Replace that DAC. And then this chip right here is probably funky. So, one thing at a time. All right, I'll be back. Okay, so I have replaced the two regulators. I've replaced the DAC. And we were getting the error, all of the RAM error and the ROM. And how this works is data is swapped between boards through this 245 and this 245 right here. So I took the easy way out and I just replaced both of them one at a time. And this one turned out to be the bad chip. Because now, in test, there's no errors. The non-volatile RAM is there because I remove it. That has a limited life cycle of write cycles. So whenever you're working on a Star Wars, remove that chip. It's right there. You don't need that in there when you're working on it. So you'll get the non-volatile RAM error. No big deal. So okay, that fixed that. That was this one right here. So now we have picture on the screen. We have the new DAC regulators, good power up there. And we're talking to each other. The two boards are able to swap data between each other nicely now. But if I hook this up to ground and move the test, and if I move the test up, look at all of these math errors. We have divider errors, we have matrix errors. So the CPU board has issues. I think that we now have this board squared away. I think this board's good to go. Now we have math issues on this thing. And if we take it out of test, how that manifests itself, there's no stars. Math errors, there's no stars. There'll be no enemies probably. I don't think we get to that in the we don't get to that anyway, but and not in attract mode. We don't get to gameplay. But let's do that. Let's fire this thing up. Let's coin. Okay. And start. And let it count down. I bet you we see no bad guys. Yeah, no bad guys, and the Death Star's going bananas. No stars, no bad guys. Garbage. Garbage. Nothing going on. We could sit here forever and this game will never end because we're not getting shot by anything. Our shield will never disappear. And we're not advancing to my knowledge. So who knows? This thing just sit here forever like this. So let's go ahead and restart. Yeah. We're back to this. So that's where we've gotten. We've so far, I think we've fixed this board. It had every RAM bad, had a bad chip up here, had a bad DAC, and I always replaced the regulators just for preventative. The caps look good, so I'm not messing with the caps. Okay. Yeah, so we've got math errors on this guy. So that'll be the next thing that we deal with. And we have some rusty, crusty chips right here I may replace just because they're rusted out. 191s, rusted. Two more up here, I believe. Yeah, these 191s, just the silver plating on these Texas Instruments chips must have corroded and must have really tarnished and then corroded, and now they're rusted. So those chips need to be replaced. And that's really the only. There's another one right there. It's probably same thing. 191, I bet. Yeah, that's the only ones though. Let me take a good look at that. Yep, that's a 191. So we're going to replace 1, 2, 3, 4, 5, 6 191s right from Jump Street. And all the rest of them look okay, I think. Those are just dirty. Yeah. Yeah. Yeah, so yeah, we'll have to go through the math section on this and really figure that out. Okay. So first things first, I'm going to turn it off and replace the 191s right off the bat, just because they're corroded and rusted. Right. Okay, we have replaced those nasty 191s, all 6 of them. Socketed. And I got the thing turned back on test, and did that fix this board? No, I didn't think it would, but those chips needed to be replaced. And we still have all kind of errors in this math. We have divider errors, we have matrix errors. So, which one do we want to tackle first? They are actually, I think they're separate. Math box test divider errors. So we can look at the divider circuit first. Why not? So let's look at our CPU board and get to the CPU board one of these days. Okay, address decoders, math address decoders. I mean, we could have a problem with the math address decoder. Maybe we should start there, I think. This looks like the beginning of this, maybe. Power input, interconnect cable. Yeah, okay. This is going to be the beginning. Here's your RAM, non-volatile RAM stuff. You know what we could do? Remember all those RAMs that were bad? Let's just pop 2 new RAMs in here and see what happens. Right off the get-go, before we even start with schematic, let's do that. You know what I think I'll do is I'm going to get my tester back out, because I did not test these RAMs. This one's got to be good, otherwise this wouldn't be working. But this is the math RAM right here. So maybe these are bad. Let's check that out. Okay, I had my Inquisitor out and I tested these 3 RAM chips and they were all good. No problem. So this is a logic error on here. Now what I think I'm going to do is upload this video as part 1, and part 2 will be basically using my analyzer on going through these math circuits until we find the chip that is bad. We have shift registers up here that are in the math section. Basic logic gate chips. We have adders that are involved in it. All the stuff that's involved with these ROMs, 10, 11, 12, 13, those are in the right spot, and I take those are probably fine. Never know, they could be bad. Could have a bad one, you know, never know. More than likely it's probably, yeah, there's these are multiplier chips, and then you have the shift registers. That's all involved in the math. So it's a pretty complex system, but part 2 of this video will go through all of that until we find the offending chip. So stay tuned. We'll see you on part 2.